Hello everyone, Jeff here with MCEP Technology again. I want to take a minute to give you a quick review on some Smart Vision lights that I have acquired here recently. These are kind of a demo test light to be able to test like what kind of light works better with your particular vision application, or to kind of give you like kind of a general consensus of what you're looking at with maybe a monochrome or a color camera. What might help make your part pop a little more, and in the contrast, brightness kind of side of things. So they actually have three different kinds that I've picked up off of MachineVisionDirect.com. Um, it sells a lot of different smart vision technology applications or components, and a lot of other different accessories. So I found them to be quite useful and helpful when it comes to some of the vision stuff that's out there. I'm also partial to banner lighting as well, with a Gardasoft controller, as well as CSS lighting with it might even be CCS. I don't remember. I always get the letters confused on that lighting that works well with the Gardasoft controllers too. But this is mainly for the Smart Vision demo Lightbox units. So I only have two of them here that I'm going to talk about. One of them is an infrared unit, which goes through several different nanometer levels of the infrared spectrum. They don't generally appear to the visual, or they don't appear to the naked eye, so there's no sense in really using them all that much. But this particular one that I'm going to show you here, and I'll zoom in on it a little bit so we can see it. So we can kind of, and I'll even try to focus it a little bit better. There we go. So this particular demo box here will give you everything from the infrared at the 850 nanometer spectrum all the way up to the UV light at 395 on the nanometer spectrum. It'll give you visible red, visible green, blue, and then white. Now, thing to keep in mind always is white LEDs, and these are all LEDs, mind you. White LEDs are generally a blue LED with a particular type of color filter across them, to make them white. So if you were to take like a light scope or a light meter that can measure the nanometer waves, it's going to pull really close to the blue nanometer readout, because it's a blue light with a particular type of filtered coloration that makes it white. So just something to keep in mind. So when you're ready to use it, you'll have to charge it when you first get them. They come with a little 12-volt DC charger that you can run. Once you get them, you basically press the little light, and then your field is going to glow that particular color. So there's white light on a really dark brown colored surface. Obviously blue light, your green light, red, visible red that is. UV is going to turn a little bit of a UV color. You can kind of see that there slightly. And I'm just curious to know, like, if okay, so that's cool. So I probably should have brought the infrared so that we could have seen that too, to see that. The camera itself is picking up the infrared light, and it's seeing the illumination on this dark colored surface here. But to our naked eye, you can't see the infrared itself. So that's something to keep in mind, is that the camera can see it, and the camera is going to turn that in because it's changing the physical photons into pixels of electrical energy. So it's changing that light into that pixelated electrical energy. So it's able to see that. The infrared box, I kind of wish we would have tried that out. It goes from, I believe, 850 nanometers all the way up to, I want to say 1350, something like that in the nanometer spectrum. It has 6 different options on that as well. What I have noticed is that the higher the number, the lesser the actual illumination, if you will, of certain parts. So definitely something to consider, and quite useful in that particular application. The other one that I brought here that we have is the UV one. And this particular UV one only goes to 365 nanometers as well as a 395 nanometer. The other unit over here that we talked about has the one to the UV 395, but the other one's a little bit more of a ultraviolet light. So obviously, you got that guy there, and then there's your 395 nanometer. And I'll go ahead and flip that up so you can kind of see that on the, you kind of see your difference there on your camera itself. Definitely a game changer when it comes to determining whether you need, what kind of particular light you need for your vision application. Really helps well, particularly the UV, like if you have like a UV adhesive or a UV glue or something like that that you're trying to make pop so that you can see that on your vision sensor. Having a different wavelength of UV light can make it pop in a totally different environment. So, like I said, total game changer for testing out lights for your machine vision application. So definitely consider these in your next machine vision application, especially if light is one of your struggles areas. So anyway, thank you all for watching, and always remember to stay safe.